All right. So today we're going to go over limiting reactants. We've been practicing with the idea that we're only limiting one reactant and we have unlimited amounts of other reactants. So if you remember on our first day, we talked about how to bake a cake. Our first set of homework, we talked about the cake where we had butter and flour and sugar. And the first couple problems assumed we had unlimited amounts of the other reactants, or the other ingredients if we're talking about a cake. But then we had that last problem, which gave us a set amount of butter and a set amount of flour and a set amount of sugar. And we said, well, how many cakes could you make with this? And I think it was a limiting reactant, and you probably ran out of butter first. I think that's right, if you all remember your homework. You ran out of butter, and so butter was the limiting reactant. Once you used up all the butter, you couldn't make any more cakes. It didn't matter how much flour you had, it didn't matter how much sugar you had, or anything else you might need. Once you ran out of butter, you were done. And that's a limiting reactant. And we do that in baking, but we also do that in chemistry. So that's what we're going to talk about today. We're going to hold off. We're going to do percent composition next class. All right, so today we're just going to be talking about limiting reactant, and then we spent some time doing practice. All right. The limiting reactant is the reactant that restricts the amount of product obtained, and the excess reactant is the reactant that is left over. All right. In the case of the cake example, the butter was the limiting reactant, and all the other ingredients were the excess reactants. Make sense? The stuff that was left over. Limiting reactant is what you run out of. It's what limits the reaction. It's what limits how much product you can make. The excess reactant is what you had extra of. Excess and extra. The excess reactant is the stuff that's left over. Extra. Help you remember that. So let's think about this. Again, this is not cooking with chemistry, so do not go home and try these recipes. But let's assume I had a recipe, it's a little bit different, where 5 eggs and 1 box of cake mix could make me 12 cupcakes. So if we did that, if I had 10 eggs and 3 boxes of cake mix, how many cupcakes could I make? 24. What y'all did in your brain real quick is what we're going to do with chemistry. Now, what you do, you said, how many could I make with 10 eggs? How many could I make with 10 eggs? 24. How many could I make with 3 boxes? 36. Which one of those is smaller? 24. And who do I run out of first? Eggs. The eggs are my limiting reactant. The cake mix is my excess reactant. It's really that simple. Just the numbers are going to change. Conceptually, that's what we're going to do. What you did automatically in your brain when you figured out how much of this you could make and how much of this you can make and what you run out of first, that's all we're going to be doing. So it's pretty straightforward. First of all, like before, we need to start with a balanced equation. And I'm going to reiterate this again. If you're struggling with balancing equations, you need to get some help. You can either work through tutorials that Tyler DeWitt provides or Marissa Maribel, or come to tutorials here in person, okay? But get some help with balancing equations if that's what you're struggling with. For each reactant, you need to figure out how much product could be formed. Just like we did a second ago, we figured out how many cupcakes I could make with the eggs, and we figured out how many cupcakes I could make with the cake mix. The smaller answer is going to give me 2 things. First of all, it's going to tell me the limiting reactant, and secondly, it's going to tell me how much product I made. First of all, it's going to give me the limiting reactant, answer that question, and secondly, it's going to tell me how much I could possibly make. So let's try this. We're going to work through a problem here. If 15 moles of aluminum reacts with 15 moles of chlorine, how many moles of aluminum chloride will be produced? I already gave you the balanced equation. So let's start with my given. I have a given of aluminum. So let's start with that one. So 15 moles of aluminum. And I need to convert moles of aluminum to what? Moles of aluminum chloride. So I'm going to write moles of aluminum and moles of aluminum chloride. Okay, and what number is going in front of aluminum? 2. And what number is going in front of aluminum chloride? 2. Just like before, we're going to cancel out my units that are moles of aluminum. And now I'm going to be left with moles of aluminum chloride. Is that what I was asked for? So hopefully we don't need to do punchy here, but how many moles of aluminum chloride would I have? 15, right? So I'd have 15 moles of aluminum chloride, assuming that I had an unlimited amount of chlorine. That's how many moles of aluminum chloride I could make. That's the first step. The second step, let's do it again, except with the chlorine. I need to convert moles of chlorine into what? Moles of aluminum chloride. So I'm going to put moles, Cl2 on bottom. What number goes in front of the Cl2? 3. What number goes in front of the aluminum chloride? 2. I'm going to go ahead and check my units. Moles of chlorine. Moles of chlorine. So now my answer is in terms of moles of aluminum chloride. Is that what I asked you for? So after I do the math here, what do I end up with? Which one of those is smallest? 10. So given 15 moles of aluminum and 15 moles of chlorine, the most aluminum chloride I could possibly make is 10 moles of aluminum chloride. So what do I run out of first? Chlorine. So chlorine is my limiting reactant. What am I going to have extra of? My excess reactant is aluminum. Questions? What questions do we have? Any questions? Good. Okay. Let's try the next one. So that was pretty straightforward. Let's try the next one. Using the same equation, except this time we're going to start with 100 grams. 100 grams of aluminum and 100 grams of chlorine. Aha, I see grams. That means I'm going to need to have the what? I'm going to need to have the molar mass. So let's go through here. At the molar mass of aluminum, again, write it down somewhere so you have it, is what? And the molar mass of Cl2, so that's 2 times 35.45. Write that down somewhere on your paper so you have it ready to go. All right, so 100 grams of aluminum. Let's do that one first. Okay. I need to convert grams of aluminum into what? Moles. So 1 mole of aluminum, 26.98 grams of aluminum. Is this a true statement? it's true that 26.98 grams of aluminum would be 1 mole of aluminum. All right, let's go ahead and check our units. All right. Now, right now, my units, if I were to do this math right now, my units would be in what? Be in moles of aluminum. But I didn't ask you for moles of aluminum. I asked you for what? I asked you for grams of aluminum chloride. So let's go next step. But I need to first get from moles of aluminum into what? Moles of aluminum chloride. You guys are awesome. Looking at our balanced equation, what number goes here? 2. What number goes here? 2. All right. Again, I want to check my units. Moles of aluminum cancels with moles of aluminum. And I look up here and it is 2 to 2. Now my answer is in terms of moles of aluminum chloride. Oh, guess what? I see another grams. We need to figure out the molar mass for aluminum chloride. So I've got aluminum, AlCl3. So aluminum is 26.98, right? And 3 times chlorine, what's that add up to? What's that multiply? 106.35. So that equals so 133.33 grams per mole. Go over here. 1 mole of AlCl3 is 133.33. And yes, 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 I want you to write all of this down. Okay. So what are the only units that are left? Grams of aluminum chloride. Is that what I was asking you for? All right, so we're ready now. We're finally ready now to go ahead and pick up the calculator and punch it in. What do we end up with? What's this number? Who's got that? So let's put some dots here so we get, because otherwise we'd only have one sig fig, right? So at 4, what is it? 494? All right, with our 3 sig figs, so we pretend that I had those up there, 494 grams of aluminum chloride. Did everybody get that? Are we okay? Do we have any questions? Good. Go ahead and do the next one. We did the hard part for you. Go ahead and do the next one. Figure out how much 100 grams of chlorine would be able to make. Did we get to this point? Questions? Concerns? Good back there? Are you okay? What number did we get after we did all our punchy punchies? So how much can we possibly make mixing 100 grams of aluminum and 100 grams of chlorine? 125. What was my limiting reactant? Chlorine was my limiting reactant. What was my excess? Aluminum. Everybody okay with that? Y'all solid? All right. Any questions on how to do limiting reactants? You're just going to do the same thing twice. Yes, sir?
If they give you like a different, instead of grams, they give you like liters and grams.
Yeah, you could convert the first, like if the first one was liter, like you could have done this with liters, maybe chlorine gas could have been in liters. You'd done the same thing, except the aluminum would have been in grams, and then the chlorine would have been in liters. And by the way, if they don't tell you a product, you just got to pick one of them. Like if this was something that made multiple products, and it said which one's a limiting reactant, sometimes we ask questions like that. So you're going to write the equation, you're going to figure out what the products are. It doesn't matter which one, as long as it's the same product for each one. In other words, you're comparing it to the same product. Yeah. All right? So let's go ahead and get our the packet out, flip over to the practice section. We're going to practice a couple of limiting reactant problems. I want to make sure everybody knows what we're doing. Let's try this problem. Actually, let's do another one first. Do the other one first. Will be easier. Let's maybe this one. Yeah, I like that one. We don't have enough time for the other stuff. Yep.
If they say oxygen instead of like oxygen gas, it's still O2.
Still O2, yeah. Anytime you say oxygen or hydrogen, chlorine, et cetera, if I say that, okay. All right, guys, go ahead and set this up. We'll check it in just a second. Make sure you know what you're doing. let them in. What do we get? So I've got grams of calcium hydroxide. What's the first thing I need to do? We got to get the molar mass. Right? Did y'all get that? So calcium is going to be what? .08? Is that right? Okay. And then the oxygen's 3200, 2.016, I think. So that's 69047. Did everybody get that? Make sure all good there. All right. That takes care of that. And reacts with 96.6 grams of HCl. That means I need to calculate the molar mass of HCl. H and Cl, it's 1.008, 35.45. So that's 36.458 grams per mole. Okay. How many grams of each product form, and how many grams of excess reagent remain after the reaction stops? So we will eventually need to do this twice. To start with, I'm just going to pick one of the reactant, one of the products. To determine limiting reactant, I'm just going to pick a product and do that and figure that out before we do it. So let's look at calcium chloride. That means I need to calculate the molar mass of calcium chloride, right? So there's calcium, which is 40.08. And Cl, 2 times that is 70.90. 89011. Did everybody get that? And I also need to calculate the molar mass of water, but we know that, right? So those are the things. I got to get molar mass on all these because I've been asked for grams. Thankfully, I already gave you the balanced equation, so you're in good shape there. All right. First thing I want to do is we're going to do 100 grams. I need to convert grams of calcium hydroxide to what? Yes, sir. Oh, yeah, it's 110. Good catch. Good. All right, so we're going to convert 110 grams of calcium hydroxide. I need to convert that first into moles of calcium hydroxide. So I'm going to have grams of CaOH2 and 1 mole. And what's the number that's going here? Okay. Again, we're going to go here. Okay. Now I need to convert moles of calcium hydroxide into what? Moles of calcium hydroxide. We're going to pick one of those two products. So let's go ahead. We'll pick calcium chloride, okay? So moles of CaOH2 and moles of CaCl2. Now what number's going here? 1. What number's going here? 1. I'm going to give you all shortcut number 1. Next class, I'm going to teach you a fast way to do these kind of problems. But I really want y'all to get some practice doing conversions, and so we're going to do a nice long way right now. So right now, if I solved it, I could tell you how many moles of calcium chloride I had. What I really want to know first is what's my limiting reactant, right? That's my first concern, because if I can solve for limiting reactant, I can figure that out. So here's my, get rid of moles, okay? So somebody go ahead and do that for me on the calculator. 110 divided by 74.096. Y'all okay? Okay, so I have 1.48 moles of calcium chloride. Now I want to do the other one, 96.6 grams of HCl, 1 mole of HCl, and the molar mass of HCl is 36.458 grams of HCl. And 2 moles of HCl and 1 mole. Okay. Cancel that out. Cancel that out. Okay. How many moles of calcium chloride could I make if I had 96.6 grams of hydrochloric acid? Somebody punchy that for me. What do we got? What'd you get? Let's try something else. So 96.6 divided by 36.458. So 96.6 divided by 36.458, we got some number. It's like 2 point something, right? And then we divide that by 2 again, right? So our final answer is, there we go, 1.32 moles of CaCl2. Which one of those is smaller? HCl. So I know HCl is my limiting reactant. HCl is my limiting reactant. That is the most, 1.32 moles of calcium chloride is the most I could possibly make. Did I ask you for moles though? I asked you for, but you know how to get from moles to grams, right? So we're going to go ahead and finish this one. 1 mole of CaCl2 has a molar mass of Do y'all understand why you don't have to do this up here, why you can stop them? Because the next step's the same. So if I do that and I do my little punchy, what do we end up with? Somebody do some punchy. What'd you get?
146.49.
Yeah, it seems reasonable. 146.49. So 5. Because we're going to do 5 sig figs, right? Or that's 3 sig figs, so let's do that. So 147. Okay. So that takes care of calcium chloride. But now that I understand that hydrochloric acid is my limiting reaction, when I want to calculate it for water, I don't have to do the calcium hydroxide. Do y'all see that? I know I'm getting rid of, I know my limiting reactant is my HCl, so I'm going to do the same thing. In this case, it says how many grams of each product. So I did it once just to figure out who's limiting and how much of that product we make. I'm going to do it again with just the HCl. And 2. Is that right? Is that right so far? Did we make any mistakes? Let's see, 2.64 times 18.016. What'd y'all get? Hang on before we leave. What'd you get? What'd you get? 47.7. Okay. So that's how much calcium chloride I could make, and that's how much water I could make. Good? All right, if you got to pass, go. All right, so I'm going to keep going here. If y'all want to work on something else, that's perfectly fine. I just need to record this. So I'm going to show y'all a couple of different ways. One of the questions this asks is how many grams of the excess reagent remain after the reaction stops. So reagent's another word for reactant, just so you're aware of that. A couple of ways to do this. I'm going to show you kind of a longer way, but there's a shorter way we'll talk about next class. I want to recognize how many moles of a product I made. And I'm basically going to work backwards and figure out how much of the excess I used up. So this was how many moles of calcium chloride I made. If I had made this many moles of calcium chloride, I would have used up all of the 110 grams of calcium hydroxide. I need to convert moles of calcium chloride to grams of calcium hydroxide, the moles of calcium chloride I actually made. So this is another reason that I stop at this stage and figure out my limiting reactant before I move on. So starting with that, now if I hadn't stopped and I had to have grams, I would need to start with grams of calcium chloride and keep going. But since I stopped and I have a record, I can go there. So 1.32 moles of calcium chloride. And I'm going to convert moles of calcium chloride to moles of calcium hydroxide. So moles of calcium chloride and moles of calcium hydroxide. And the number for calcium chloride is 1. Number for calcium hydroxide is 2. And so I'm going to convert that. Then I need to get from moles of calcium hydroxide to grams. And I can do that looking over here. There's my molar mass. So 74.096 grams of calcium hydroxide. And 1 mole of calcium hydroxide. What's that? This one? Reagent. It's another word for reactant. All right? So now I'm in a position, I'm going to multiply 1.32 times 74.096. Do that real quick here. 2 times 74.096. That is 97.81. We'll do that. Let's see, grams of calcium hydroxide. This is how much was used. That's how much was used up. That doesn't answer my question. That does tell me how much was used up. So I'm going to subtract 110.0 grams from the amount that was used up. So I'm going to do that right over here. 110.0 minus 97.8. That really should be what it was in terms of sig figs. So this is 2, and this should be what? 13? Is that right? No, 12, right? So 12.2 grams of calcium hydroxide left over. That's how much was remaining. Let me double check that because I don't trust my brain. Yep, that's correct. So I used up all of the HCl. We ran out of HCl. We made 47.7 grams of water. We made 147 grams of calcium chloride. And we had 12.2 grams of calcium hydroxide left over.